Okay, Assalamu alaikum Abdurrahman. So I'm just going to do this worksheet here. So with this question, you're trying to find moles with another number of moles. So usually we'd use that formula, but remember big N is atoms or molecules or particles, so I actually can't use that formula. So what we do with this, so whenever it's a calculate number of moles from number of moles, what we do is, it says for each element. So we have 3 elements. We have calcium, phosphorus, sorry it's a bit blurry, wait, hold 1 second, stupid phone, okay, and oxygen. Okay, so we want to find, and it says of each element, so we want to find the moles of each one. So I write small n, which means moles. I put Ca in a bracket, so moles of calcium, moles of phosphorus, moles of oxygen. So to find the moles, we have 6 moles of this big thing. I'm going to write 6 for each one first. Doesn't really matter. And here we can see we have, I know it's a bit hard to see, we have 3 calciums. It's getting blurry whenever I go close. Okay, now it's blurry for some reason, wait. Okay, so yes, we have 3 calciums. So the calcium, I'm going to times it by 3, which means I have 18 moles of calcium. For phosphorus, I have 2, because here, I'll just rewrite this again, because I know I wrote too much on it. So because inside the bracket, here I only have 1 p, but outside the bracket is 2, so 2 times 1 is 2, so I have 2 p's. So 6 times 12, which is 18 moles. And then for oxygen, I have 4 oxygens inside the bracket, and there's a 2 outside, so it'll be 4 times 2, which is 8. So I do 6 times 8, so equals to 48 moles. Okay, hope that makes sense so far. Then if I want to find, now it says for the second question, calculate the number of atoms in each element. So I want to find for each element. So all I do is, so atoms we know is big N. So I'm going to use this formula here for question B. Okay, so big N for Ca, big N for P, N for O. And all we do is whatever answer I found in the previous question, I'm going to multiply it with Avogadro's number. So 10 to the power 23 okay, so just multiply. So whenever I want to find atoms, I just multiply with Avogadro's number. And whatever answer you get, because it says how many atoms, the units will be in atoms, whatever answer you get. Okay. So second question is exactly the same, so I'm going to skip that one, and I'll do question 3. So question 3 is a little bit different. Okay, so wait, hold on. Stop blurring out. Anyway, question 3, where you have the worksheet, so hopefully you can, it's really blurry. Okay, so it says calculate the number of moles of each ion instead. Now because you weren't here, you don't know what an ion is. So an ion is something with a charge. So you can, in every element, you can only have 2 ions. One that's positive, one that's negative. So in anything, the first element is going to be a positive ion, and the second one is going to be my negative ion. So there's only 2 ions. So if it said each element, but it doesn't say element, if it said each element, then it would be aluminium, sulfur, oxygen. But because this is ion, our first ion will be aluminium. and our second ion will be sulfate, which is this SO4 in the brackets. So the way you'll know your ion, it'll always be in like a bracket, or it'll just be everything that's not our metal. So metal was by itself, so everything else will be our ion. So that SO4 is my ion. So I'm going to write the SO4 as a whole thing. They do have charges. The way you can tell the charge is the opposite number. So because SO4 has a number 3 here, because the numbers got swapped, so because SO4 has a 3, that means aluminium's charge is plus 3. So the first element has a positive charge, the second one has a negative charge. And because the aluminium has a 2 here, that means the charge of SO4 was 2 minus. This part you don't have to know too much. It's given in your test anyway. I'm just explaining it. Now we do the exact same thing. So we're going to have 4 moles. So we do 4. I have 2 aluminiums there. You see there's 2 aluminiums there. So I do 4 times 2, which is 8 moles. And then for the SO4, so what you do is you just look at the number outside of the bracket. So you can see I have 3 SO4s. If it was not in a bracket, that means I just have one of it. Okay? So if it was like this, I know this isn't accurate, but if it was like this, for example, without any bracket, that means I just have one. So one of this, I only have one. Okay? If here I had a 4, that means I have 4. Okay? Anyway, so we know we have, because there's a 3 outside the bracket, so I have 3. So I'm going to multiply our moles with 3, which is 2, 12 moles. Then I do the exact same thing that we did in the previous question. So we're going to find big N now, because it's the number of atoms. So I do Al plus 3, so 4, 2 minus. So the moles for aluminium was 8. So I do 8 times Avogadro's number, whatever answer that is in atoms. And same for SO4, 12 times 2 times 10 to the power of 23. So however many atoms. Okay? Second question exactly the same, so give that a try. So I'll skip that for now. And then for this question, so this you've done before. That's just finding, what's it called? Finding percentage composition. The only part you haven't done is this one here. So if I want to find that, it says I want to find for copper. So at the top, I would just do AR of my copper over MR of the CuFeS2 and multiply it by 100. Answer was, I think, 34.6%. I can't remember 100% when I did it in class. So the hard part is, well, it's not the hard part, just the question's a bit confusing. So it says our thing, our chalcopyrite samples, like a type of rock, it only contain 30% of this. So what I do is I write my answer from the previous question up there. I'm going to multiply it with 30 here, and I'm going to divide it by 100. That'll give you answer. That'll be about, I think, 10.86%. I can't remember the number. Maybe about 10 something percent. So I hope, inshallah, that makes sense. If you need any help, just send me a text, inshallah.